So this is a basic MOSFET current mirror circuit where you are using a reference current source at Q1. Okay, so this means that by using a simple resistive network, you have generated a required reference current, and I have fixed this in this particular terminal. Okay, and by using transistor Q2, if it is perfectly matched, you can get the same current I0, which is equal to IRF. But if you are using an unmatched transistor, and if the aspect ratio of Q2 is double as that of Q1, then I0 will be 2 times of IRF. Or maybe if it is the aspect ratio of Q2 is half of Q1, then it will be 0.5 of IRF. So likewise, you can set appropriate current I0 at the required terminal of an IC. This is called as a mirror circuit. But in mirror circuit, specifically here I have mentioned mirror. That means you need to take Q1 and Q2 as a matched. So kindly understand that mirror is not a, mirror is a kind of source, but it is a special case of source circuit where you have used two identical transistors. So always I0 will be equal to I reference. Okay, that is simply you are replicating the same current again and again to other part of the IC location. This is what we are doing. So here you can see V naught is a voltage across Q2 and I naught is a current flow through Q2. V naught is the voltage across Q2 and I naught is a current through Q2. Okay, so the input reference current is being supplied by a current source for both simplicity and generality, and the current gain or the transfer function. Current gain means it is a ratio between the input and output current. Your input current is IRF and the output current is I naught, which is given by the ratio of their respective aspect ratios. So I naught by I reference is called as, what is I naught by I reference? It is called as the current transfer ratio or current gain. Current transfer ratio or current gain, and based upon this equation we can generate the required current at the output. But for a current mirror, always this ratio will be 1:1, so that I naught will be equal to I reference. So this is just a theoretical way. Okay, that is need not necessary that always I naught will be equal to I reference while you implementing a practical current mirror circuit, because this ratio can be changed. It is not required that always it will be 1:1. If at all we are using the matched transistors also, there are some practical constraints. So, but theoretically you can tell whenever the ratio of the aspect ratios is maintained as 1:1, then I naught will be same as that of I reference. But in practical cases, there are some constraints where I naught will be changing according to some aspects. So let us discuss on what basis this output current is changing. So that we are going to discuss effect of V naught on I naught. Okay, so understand that I naught is same as that of I reference for a mirror circuit, provided the two transistors are identical in terms of their aspect ratios. But still, if you are using the same identical transistors, still there is a scope of changing this I naught. Understood? It won't be same as that of I ref. There is some practical constraints that is going to affect this I naught. It won't be same as that of I reference. There will be an incremental or decremental change. So that is affected by V0. So V naught is going to affect or determine this I naught value other than I reference. Of course, I naught is equal to I reference, but in practical implementation, V naught is also determining this value of I0. So now we are going to discuss how this V naught is affecting our output current I naught. What is V naught, students? V naught is the output voltage of Q2. Clear? Theoretically, I naught will be equal to I reference for a current mirror, but practically this I naught is going to be determined by V naught as well. I hope the concept is clear. Okay, now take down this particular point, all of you. So the main point is we need to make the transistor Q2 to be in saturation. Okay, so already I told Q1 should be in saturation. At the same time, Q2 should be also in the saturation. Okay, now what is the condition for the Q2 to be in saturation? Again, this is an N Mosfet, right? So tell me the condition for saturation. VDS should be greater than or equal to VGS minus VT, right? What is VDS here, students? Tell me what is VDS here. Is it equal to V Naught? Across drain and source, we are having V0, right? So we can write the equation of Q2. That is the condition of Q2 to be in saturation as V Naught greater than or equal to VGS minus VT. Clear? So I'm going to maintain both Q1 and Q2 in saturation, right? So in order to maintain Q2 in saturation, I should write the condition that is V naught is greater than or equal to VGS minus VT. Now what is VGS minus VT? VGS minus VT is nothing but the overdrive voltage. VGS minus VT is the overdrive voltage. So if you maintain the output voltage greater than or equal to the overdrive voltage, then we can maintain Q2 in the saturation. Okay, but the main problem with us is the channel modulation effect. You know what is channel modulation effect? We have already discussed it in the working of the Mosfet in the introductory classes of this particular subject, right? That is during the saturation region, that is if you increase the supply VDS, that is drain to source voltage, correspondingly the pinch off will happen. Channel will be starting to get pinched off. As a result, it is going to affect our drain current also, right? So rather than maintaining a constant drain current, we are having a slope in the curve. That slope is nothing but the reciprocal of resistance R0, that is 1 by R0, where R0 is your ratio of early voltage divided by the drain current. Again, I'm telling that is in the saturation region, even though you are expecting a constant current flow, but because of the main problem of channel modulation, channel length modulation, that is your pinch off process, you will always experience some slope. Understood? A small slope will be there in your output curve, that is in your drain curve, drain current curve. So that slope is nothing but due to a finite output resistance, small letter R0. Okay. Now here we are connecting the two transistors in such a way that the gate voltages have shorted together and the source terminals are also shorted together, which means their VGS will be same. Their VGS will be same. Okay. Now, if the two devices are matched devices, then their VDS will be same and correspondingly your output voltage will be equal to VGS. How you can tell that your output voltage is equal to VGS? Because as per your transistor Q1, the drain voltage is equivalent to VGS. That is VDS is equal to VGS for Q1. But for a current mirror circuit, you are taking two identical transistors. So in that case, what will happen? This VDS will be equal to this VDS also. So if you are using a matched transistors, the VDS voltage, the drain to source voltage of both the transistors will be same. Then we can say that since VDS is equal to VGS, right? Then V naught is also equal to VGS. Are you getting my point? Again, I'm explaining. Since the two transistors are the matched transistors, their drain to source voltages will be same. But what about the drain to source voltage of Q2? It is equal to V0, isn't it? So V0 is equal to this VDS. But this VDS in turn, it is equal to what? This VGS, as your drain and gate are short circuited. So eventually you can write V naught is equal to VGS. Clear, students? V naught is equal to VGS. Any doubts? Please write that point. How V naught became equal to VGS. Okay. Okay. So when V naught is equal to VGS, I naught will be equal to I reference. then only that mirroring will happen, right? Mirroring or replication will happen only if the output current is same as that of reference current. But this will happen only if the output voltage is equivalent to the gate source voltage. But because of some reasons, your output voltage may not be exactly equal to VGS. It will be greater than that of VGS. In that case, you can expect some fluctuations in your output current, which will not be equal to the reference current. Understood? So please write this condition. Only if V naught is equal to VGS, you can write I0 is equal to IRF. How V naught become equal to VGS? Because I have taken two devices as matched devices, because of which the VDS was same. As a result, V naught is equal to VGS, because of which I naught is equal to IRF. Right? But what happens when V naught becomes greater than VGS? You can expect some fluctuations in your voltage. Accordingly, your I naught will change. It will not be equal to I reference. So that change we need to consider here, and how we are going to write a equation for corresponding to this particular change in your current. So this change in I naught will result in a resistance called R0, right? So that R0, output resistance R0, is nothing but the change in the voltage divided by the corresponding change in current. Actually, you require to maintain this equality, right? But due to some reason, we are having a change. So what is the change in the voltage? What is the difference in the voltage? The difference in the voltage can be denoted as V naught minus VGS divided by, accordingly, your current has also changed. So that change in your current can be written as delta I0. So change in output voltage divided by change in current, output current can be denoted as a resistance R0, given by equation number 1. Clear? Any doubts? So what I meant is, if you are maintaining two transistors or matched transistors, then your output will be equal to VGS theoretically, and accordingly I naught will be equal to I reference. But due to some critical situations, if V naught is not equal to VGS, even though you use matched transistors, then correspondingly you can expect a change in your output current. So that output voltage change divided by output current change can be modeled as a fixed resistance called output resistance capital R0, which is defined by particular equation. That is R0 is equal to V naught minus VGS divided by delta I0. So remaining portion we will cover it tomorrow. So the portion is, what is the effect of V naught on I naught? Because I naught is no longer same as IRF. It is a different value which is going to be changed by this V0. So that we are going to derive it in an analytical way. The remaining portions we will continue tomorrow. So kindly revise. Thank you. Any queries? Thank you all.